Hello and welcome back to the fourth episode of my God of War tutorial series. Today we will deal with adding landmarks to our world and then later to our raider. If you've played God of War, you might know that this feature isn't included there. However, some people in the community asked for it, so we'll implement it anyways. Landmarks are points of interest in your world that will always be visible on the raider, so in that sense they're similar to our directions. However, they aren't based on a rotation in the world, but an actual position. So putting it in a nutshell, you could say that there's somewhere in between the directions and actual quest markers. If we have a look at our level here, I just very quickly added something that could represent a tower in here. And here's some boxes that we will use as a representation of a town. Because if you have a look at our textures folder, you will get the landmark tower and landmark town. So these are the two examples I'll show you how to set up. And first off, we need a widget that will display these icons on our raider. Hop over to the widgets folder and create a new widget blueprint that we will call w_landmark. Then I'll open it up, and like with all of the other sub widgets, make your setting here desired on screen. We don't need a canvas panel. Usually we start off with a size box to make sure that the widget always has the same size, even though if we place it inside of other widgets. However, if you have a look at our textures again, landmark tower and landmark town, you can see that these two don't have the same size. So the landmark tower is 20 by 36 pixel and the town is 27 by 26 pixel. So the icons that we use don't necessarily need to have the same size, and because of that we won't use a size box. Instead, the only thing we need here is a simple image that we will drop onto our hierarchy, and let's call that the icon. Make sure it's a variable. We later need to change the brush here. And let's just select landmark tower as the default. You will see that the size of the widget adjusted to the size of the image. Just so that the landmark isn't such an eye catcher, we'll lower the alpha to 0.6 to make it a little bit less opaque. And that's it already for designing your widget. So let's go to the graph and do the functionality. We only need one variable in here that we will simply call the landmark icon. So that will be the texture that we set our image to, either the tower or the town. Of course, you could add multiple textures according to what you need in your project. And the type here will be a texture to the object reference. Let's also make it editable and exposed on spawn. The only thing that we want to do in this widget is setting the image to the landmark icon, and that we can do on event preconstruct. So simply grab your icon, and you might remember that in the previous episodes, in such cases, we always use the function that is called setBrush from texture. However, in this case we can't do that because, like I already mentioned, our brush will have different sizes. So the image size here also has to change, and that you cannot do when using this function. So let's remove that. Instead, we will simply set brush and hook that up to event preconstruct. Then we will split the in brush and you get an in brush image size. So let's split that too. So we get X and Y. We want to make it so that these values match the dimensions of our landmark icon. Simply grab your landmark icon, and it contains a variable that is called size X. Get size X. We'll also get size Y. And then we'll just hook them up to the inputs here, and it will be automatically converted to a float for us. The only thing left that we're missing is the brush image. So for that, simply connect your landmark icon. Okay, then we can compile save. And if we head over to the designer, you see that there is no image appearing. That is because the default value of our landmark icon currently is set to none. So let's simply choose the landmark tower, compile save. And there we see it in our designer. Where to select the landmark here and just hit landmark town. That will change. And you see that the dimensions of the landmark town are properly displayed, so it isn't stretched or something like that, which is good. That's it already for this widget. So compile, save, close it. Like with all of the other sub widgets, we need a function on our raider to add that onto the overlay in here, this overlay. If we have a look, just drag in your landmark onto the overlay. The only thing we need to do here is align it to the center. All right, we don't need any padding here like we did for our quest markers, so we can remove it. And in the graph, first off, we created arrays for all of the other widgets that are added to our overlay. So we want to do the same thing for the landmarks. Add a variable called landmark widgets. And here the type will be a w_landmark object reference, and it will be an array. Then we need a function called add landmark. It has one input, and this will only be the icon of the landmark, so a texture 2D. reference. Could simply call that icon. Let's also give that an output called widget, so the item that we created, and that will be a w_landmark object reference. The logic in here is extremely similar to the other functions add marker and direction. So you simply create the widget you want to have, create widget, and select your landmark class. We'll be asking you for the landmark icon, so that is where our input here comes in place. So hook it up. Then we want to store it in this array, so later we can update the position on the radar. Add an element and hook up the return value. Then to display it, we need to add it to the overlay too. So let's get the overlay and add child to overlay, with the content being the return value of our create node. Like I said, we still have to set the alignment to center, otherwise our widget would appear in the upper left corner. That's not something that we want. So off of the return value here, set horizontal alignment to center, and also set vertical alignment to center. After that, you can go into your return node and it will be asking you to select a widget, so that will come from our return value all the way to the left. Compile and save. And close our radar too. For landmarks, we will do something different to what we did with quest markers and the directions. We won't add them to the radar during runtime, but we will make it so that when we are designing our level, we can simply place landmarks in our world. And when we start playing, our radar will gather all of the landmarks that were placed in the level and display them on the radar itself. To be able to do that, we need something like a landmark class that we can place. So let's go to our radar system folder and let's add one subfolder for classes. Go in there and create a new blueprint class. Parent class will be actor. There is no similar class to a landmark that we could use as a parent. We will just call that bp_master_landmark and open it up. In the viewport, we will add one component, and the only thing that we want to display when adding a landmark is a larger version of the actual icon of it, and that you can either use with a sprite component or something that is called a billboard. So let's add that. Drag that on top of your default scene root to make it the new one. And here you can select the sprite. So let's look for our landmark town. That's very small. So just so that we don't have to zoom in when designing our levels, we will bump up the absolute scale here to, let's say, 4. That looks better. And then we need one variable in here. So we will call that the icon on radar. That will be a texture to the object reference. Also make it editable and expose on spawn. That just means that later when we drag actors of that into the level, we can change it per actor and don't need to create child classes off of this parent class every time. And we also wanted that our billboard here represents the icon on radar. So in the construction script, which is also called in the editor, events like begin play are only called when starting the game. So for this here, we need the construction script. Simply get your billboard and set sprite. And the new sprite is your icon on radar. Simple as that. So also select the icon on radar, and if we compile, give that the default of the town. Okay, have a look at our viewport. So that's the town currently, and if we select the tower, that would change because of our construction script. Compile and save. Now we can close that class and let's drag some landmarks into our level. So we will start here where I built something like a tower. Let's drag that in, move it up. And just somewhere here. Landmark tower is fine. And then I'll just hold Alt while dragging to create a copy and move that somewhere in the middle of that boxes that will represent the city. Somewhere here, that should be fine. And I'll just select the landmark town here. If we start playing, you won't see these icons because they're billboards, so only visible in the editor, which is exactly what we want. Now we need our radar to gather all of the landmarks on begin play and add them onto the radar. So let's go to components and the BPC radar component. In here we also want to store all of the landmarks that we are displaying. So let's add a variable, call it landmarks, and the type here will be BP master landmark object reference. We'll make it an array so we can store more than one, and let's make it private. Then we need some functions. So the first one will be called add landmark to radar, which needs one input. So the landmark that we want to add, just call that landmark, and same type as our array, so a master landmark object reference. We will first check whether our array already contains this landmark. So drag in your array and get it, then look for contains. hook up the input, and off of the boolean here, let's add a branch, hook that up to the execution. If it's true, we can simply return. Don't want to add the same landmark twice. However, if it's false, we can grab our array again and add an element, hook up the input, and then we also want to display that on our radar. So let's grab the radar widget reference, check whether that is valid, just to make sure we don't access any non-valid variable. And if it is valid, off of it, add landmark. We'll be asking you for an icon. So to grab that off of your input, simply look for radar and you will get the icon on radar. Right, let's hook that up and add a return node. Then copy paste that for is not valid. Got the functionality to add radar widgets. Currently they would just stay at the default position in the very center of our radar. We still have to update them. And let's have a look at our update marker positions, because that function is extremely similar to what we have to do to our landmarks. So we will simply duplicate that and call it update landmark positions. Instead of grabbing the marker widgets from your radar widget, we will get the landmark widgets. And you can't plug that in for the for each loop because that is bound to the type that you connected when adding it the first time. So let's look for a fresh for each loop, hook up our landmark widgets array. And we want to make it so that all of the wires that come out of this array element will go to this one. So simple trick, just hold down Control, grab it, and drag them onto the array element, and do the same thing for the array index. Then you can remove the old for each loop, hook up the new one to the execution, connect completed to the return node, remove the marker widgets, and hook up the loop body to the branch again. The only thing that we need to change is that here we're still getting the quest markers. What we want to do is grab the landmarks and get from that at the array index and simply get actor location. Then you can plug that in for the target and remove the quest markers here. Compile and save. Let's close these two functions and let's head over to the event graph. When we initialize the radar, after we added markers for all of the default quest markers, we want to add some room and we want to gather all of the landmarks in our world. So the function you need here is called getAllActors of class. Class will be the master landmark. And then off of the out actors, we want to run a for each loop. Because for every element, we want to call add landmark to radar and hook up the array element as the landmark. Then once this is completed, we can go into all of our update calls. And here, before we add the main widget to the viewport, let's also call update landmark positions. Right, so all of our landmarks are gathered and displayed on the radar and updated for the first time here. They also have to be updated when our player turns around. So let's call update landmark positions at the very end, and also when moving, because are based on a location. And depending on our player's location, the position on the radar could also change. So update landmark positions here. If we compile and save, we can already test. Alright, so now I'm in play mode. On our radar you can see two different landmarks. More to the left side, there is the town, and a bit to the right side, there is our tower. If I turn around, the position updates, and also if I move around, it also does that. So here would be our tower, and this would be the city, or the town. In the comments section of the last episode, I was also asked how you would go about removing quest markers from the radar, because currently we've got no functionality for that. So let's have a look at how that would be done. Let's open up the radar component, and we will add two functions to make that happen. First one will be called remove quest marker. Give that one input, and that should be the marker that we want to remove. If we have a look at our markers array, these are s_marker info structures. So that will also be the type here, s_marker info, and just call that marker or marker to remove, whatever is clearer for you. And we will also give that an output of type boolean called success. So are we able to find that element in our markers, and if so, did we properly remove it? First off, grab your quest markers and we will try to find an item. That will be the input. If you hover over the return value here, it reads the index the item was found at, or -1 if not found. So off of it, let's check whether that is greater or equal to 0 and add a branch. So if it's -1, means we didn't find anything, then it will go to the false path here. The find node plus an greater or equal to 0 is basically the same thing like a contains node. However, we need the index here later, so it might be a little bit more elegant to use the find node instead of the contains node. If it's false, just go to the return node with success being false. If not, however, grab the return value and we'll promote that to a local variable called local index and hook that up to the true path. Then we will grab our quest markers array that stores all of the information about the markers that are currently displayed. And we want to remove an index. And that index will simply be the local index. When working with arrays, you have to keep in mind that if you remove an index, all of the indices behind that shift by 1 to fill out that empty spot there. Just keep that in mind if you ever work with arrays and remove items. We removed it from the array. It would still be on the radar, however, because the widget is not really related to our structure array. Let's grab our radar widget reference and grab the marker widget, then get from that at the local index. And to destroy this widget, you need to call a function named remove from parent. All right. So that will no longer be shown. The problem of that function here is the widget reference will no longer be valid. However, it still occupies a slot in our marker widgets array that would just be null. So off of your marker widgets, we also have to remove an index there, and that will still be the local index. So these 3 nodes are all of the functionality you need for removing a quest marker. After that, copy paste your return node and hit the success boolean. Compile and save. The input here is a marker info structure. It isn't very convenient for us to always find out what the type and position of a marker is to remove it. So we'll add another function called remove marker or quest marker at index and give that an input of type integer called index and an output of the type boolean called success. So in this function we will not worry about the structure info. We will just say, for example, if the index is 0, remove the first element in our quest markers, whatever that is. And first off, we have to perform a branch here to check whether our input is valid, because we need to see whether that is in range integer of 0 to the last index of our quest markers. So grab your quest markers, last index, and hook that up to max. And we want to check for the second condition, because we want to know whether the length of our quest markers, which means the amount of elements in there, is greater than 0. So is there anything in our array at all? If not, we don't even have to perform that checks here. Plug that in for the condition, and if it's false, again return with unsuccessful. If it's true, we will remove quest marker, so call our function we just created. And to grab that marker, drag in your quest markers and let's get a copy at the input index, then hook that up, and we will copy paste our return node and connect success to the output success of this function. Save. All right, the functionality is there. You've got 2 different ways of removing a quest marker, either by an index or by a marker info, which would be the type and position. We still need to call it somehow just to check whether that's working. And we will simply assign 2 number keys on our keyboard to check that. So 1 and 2 to remove the first and second element. Let's go into our third person character for that. And somewhere in here, we'll just look for 1 and for 2. Drag in your radar and we will call remove marker at index. If we press 1, the index would be 0, so the first element. If we press 2, it would be index 1, which would be the second element. Make sure you hook up the radar as a target for every call here. And if we compile, save and test, that should also be working. Before we test, let's have a look at our third person character at the radar here and expand the default quest markers. So the first element would be the side quest and the second one would be the main quest. That's important for testing. Now if I hit 2, our main quest should go away, which it does. Now if I hit 2, nothing should happen because there is no second element in our quest markers array. Yep, I'm hitting 2 and nothing happens. And if I hit 1, our side quest would be removed. I just quickly restarted the level. If you start with hitting 1, your side quest would go away. And if you hit 1 again, the main quest would also go away because, like I said, the index will shift once you've removed the first element. So now the main quest is element 0, and if I hit 1, that is also removed. Alright, that's the end of this episode. We've got landmarks working and also made it possible to remove quest markers from your raider. In the next episode, I'll show you how you can highlight your raider and change its color when you're close to a secret. So that's another feature from God of War that we will implement. See you then.